Alright, this lesson is on solving rational equations. We're going to start with this equation. Two over x minus 3/2 equals 7 over 2x. What we do first when we solve a rational equation is we get rid of all the fractions. And to get rid of all the fractions, we multiply both sides of the equation by the LCD, or the common denominator. So I'm going to write that down. Multiply both sides by the least common denominator. That's the first step to solving a rational equation. Now, for the equation which I have here, the LCD is, let's see, if we got an x, we got a 2x, we got an x, we got a 2, and we got a 2x. The LCD is the 2x, the least common denominator. So I'm going to multiply both sides of the equation by 2x. Like that. Now, if we distribute this, we should eliminate all the fractions. 2x times 2 over x minus 2x times 3/2, and over here 7 over 2x times 2x. Here, where the x's are gone, and we're left with 2 times 2, which is 4, minus, here the 2's are gone, and I'm left with a 3x, and here the 2 x's are gone, and it leaves me with 7. All the fractions are gone. I now have a much simpler equation, 4 minus 3x equals 7, which I can now solve by subtracting 4 from both sides. Divide both sides by -3, and I get x is -1. Solution to the equation is -1. Well, actually, whenever you are solving a rational equation, which you do have to make sure of one thing, and that is make sure that the solution which you get does not cause division by 0. So you notice in the original equation here, if x is 0, I'd have division by 0 there. And so if I got 0 as an answer, I'd have to rule it out. We'll see one of those in a little bit. Let's try another one like this. Let's solve the equation. -3 over 20 plus 2 over x equals 5 over 4x. Okay, the very first thing we do is we multiply both sides by the LCD. And for this equation, the common denominator for 20 and 4 would be 20, and I have an x here and an x there, so I'll just need an x to the first. All right, we talked about finding LCDs in a previous section, so you should be familiar with that. I'm going to multiply both sides by 20x, just like that. Now I distribute. (20x) times -3 over 20 plus 20x times 2 over x equals 5 over 4x times 20x. Let's simplify. Here we have the 20's which disappear, and we're left with a -3x. Right here, the x's are gone. I'm left with 20 times 2, which is a 40. And here we've got, let's see, we got x's which are gone, and 4 goes into 25 times, so that's going to be a 5 times a 5. I believe that's a 25. Okay, I've multiplied both sides by the LCD, and all these fractions are gone. So now I'm going to subtract 40. -3x equals -15. And negative 15 divided by negative 3 is a positive 5. The solution to the equation is 5. Okay, next. Let's look at one that's a little bit bigger. 2 over x minus 3 minus 3 over x plus 3 equals 12 over x squared minus 9. Okay. Once again, we're going to multiply both sides by the LCD. Now, I notice here that x squared minus 9 will factor to x plus 3, x minus 3. So what I would do first is actually just write that in its factored form. There it is, x plus 3, x minus 3. Okay. So the LCD for the entire equation is x plus 3, x minus 3. There it is. So I'm going to multiply both sides by that. This whole side times x plus 3, x minus 3. And this entire side times x plus 3, x minus 3. So this should get rid of all the fractions for us. Now this times this, the x minus 3's are gone, and that leaves me with a 2 times x plus 3. If I multiply this to this, the x plus 3's cancel away, and that leaves me with a 3 times x minus 3. And on this side, the only thing that's going to be left is 12. I've eliminated all the fractions. Now I'm going to solve this equation for x here. I will distribute 2x plus 6 minus 3x plus a 9 equals 12. Combine your like terms. 2x minus 3x is negative 1x. Plus 6 plus 9 is plus 15. Subtract 15 from both sides. Negative 1x equals negative 3. And divide, and we get 3. Now, remember what I said earlier. When you are solving a rational equation, you have to make sure that you don't have an answer which will cause division by 0. So if I take a look right here, if x is 3 and I go up to the original, notice that right there, if I plug in 3 for that x, I've got 2 divided by 0. Two divided by 0 right there, which of course is undefined. The answer I got causes division by 0 in the original equation. Therefore, x minus 3 really is not an answer. It's actually called what's called an extraneous solution. An extraneous solution. This equation really has no answer at all. And so what I would write is empty set. Where am I going to fit it in here? Oops. Okay, I'll just write no solution. How about that? No solution to this equation. Okay? We always have to check our answers and make sure that they do not cause division by 0, and this one did. All right, moving on. Let's try this one now. 3 over x plus 1 equals 1 over x minus 1 minus 2 over x squared minus 1. Just like the previous example, I notice right here that x squared minus 1 factors to x plus 1, x minus 1. And that is the LCD for the entire equation. LCD is x plus 1, x minus 1. So I'm going to multiply both sides of the equation by that. This side times x plus 1, x minus 1. And this entire side, x plus 1, x minus 1. Okay. On the left, x plus 1's will cancel away. and we're left with a 3 and an x minus 1 right here. That's the mess. On this side, on the right side, we have to distribute this times this fraction. The x minus 1s are gone, and I'm left with a 1 times an x plus 1. Minus this whole thing now times this fraction. The x plus 1, x minus 1 here completely cancels with that down there, and the only thing you're left with is that 2 in the numerator. I've eliminated all the fractions, so now let's distribute. 3x minus 3 equals x plus 1 minus 2. 3x minus 3 equals x minus 1. Subtract x from both sides and add 3 to both sides. And I've got 2x equals 2. X is 1. And now if you notice, if you go up to the original equation, right here this tells me that x cannot be negative 1. This one right here tells me that x cannot be positive 1. And notice what I got as an answer, x equals 1. So x equals 1 is going to cause division by 0. And so that's not really a solution. This equation has no solution. No solution, just like the previous example. Okay, let's try one like this now. One over x plus 4 plus x over x minus 4 equals negative 8 over x squared minus 16. Okay, just like in the last two examples, I have this x squared minus 16, which I know factors, so I'm just going to erase that and write it in its factored form. X plus 4, x minus 4. It's one of those difference of squares. That's the LCD for the entire equation. So I'll write that up here. The LCD is x plus 4, x minus 4. So I'm going to multiply this entire side by that. And I'm going to multiply this side by x plus 4, x minus 4. Distributing now. This times this. The x plus 4s are gone, and that leaves you with just x minus 4. My LCD times this fraction here, the x minus 4s are gone, and that just leaves me with an x and an x plus 4 multiplied together. On this side, everything's gone except the negative 8. Okay, I've eliminated all the fractions. Let's distribute this. I've got x squared plus 4x equals negative 8. Combine your like terms. Let's see, x squared plus 5x minus 4 equals negative 8. Okay. In this equation, I eliminated all the fractions, but I ended up with a quadratic. There's an x squared in here. And so to solve this, I'm going to resort back to what we learned in the previous chapter. I'm going to solve it by factoring. I'm going to move everything over to the left side, setting the equation equal to 0. Let's see, if I add 8 to both sides, that would be plus 4. Fix that. Okay, x squared plus 5x plus 4 equals 0. I can factor the left side. Plus 4 and plus 1. And so if I use my zero factor property, I will end up with two possible solutions. Negative 4, negative 1. Once again, I have to check and see what's going to cause division by 0 in the original equation. If I go up to the original equation, I can see right there that x cannot be negative 4. And right here, that tells me x cannot be positive 4. It can be neither one of those. So I have to rule out that negative 4 as one of my answers. The only correct solution is negative 1. Negative 1 is the solution to our equation. All right, let's try another one like that. 2 over 3x plus 1 equals 1 over x minus 6x over 3x plus 1. The LCD for the equation is, well, I have an x here, so I need an x. And this has a 3x plus 1, that has a 3x plus 1, so remember you only need one of them. So my LCD is x times 3x plus 1. That's what I'm going to multiply both sides of the equation by, so here I go. This side times x, 3x plus 1, and this side times x, 3x plus 1. Now, on the left side, 3x plus 1s are gone, and I'm left with 2x. Over here on the right side, I've got this times this. The x's will cancel away and leave me with just a 1 times a 3x plus 1 minus this times this fraction. The 3x plus 1 disappears here, but that leaves me with this 6x and that x that's left, 6x times x, and that's 6x squared. Okay. I've eliminated all the fractions, so let's distribute. 2x equals, that's just 3x plus 1 minus 6x squared. Okay, this is a quadratic again, so we are going to solve it by factoring, and I'm going to move all the terms to the left side, setting the equation equal to 0, combining any like terms along the way. And so that will leave me with 6x squared. Let's see, minus 3x over here, that'd be a minus x, and then minus 1 equals 0. There. If we combine our like terms correctly, we should end up with that. Now we need to factor the trinomial here. Factors of -1, plus 1, and minus 1. Only one option. 6x squared, that could be 6x times x, or it could be 3x times 2x. So using my trial and error method, I'm going to try the 3x and the 2x. And I'm going to put the, let's see, the plus 1 here and the minus 1 there. And as you recall from the previous chapter, a quick check. You multiply that together, you multiply this together, and that adds up to the correct middle term right there. See, so I know I have it factored correctly. Let me move that out of the way. Move it out of the way. Okay. So 3x plus 1 equals 0, or 2x minus 1 equals 0. If I solve this one, I get -1/3, and if I solve this one, I get 1/2. Now we got to make sure we don't have any division by 0 problems, so let me go up to the original equation. If we go right up here, 3x plus 1, if that's equal to 0, if I solve that, x cannot be equal to -1/3. -1/3 causes division by 0. And notice I have one here. I cannot use that. I got to rule it out. The only correct answer will be 1/2. Solution to the equation is a 1/2. Okay, one or two more examples in this section. Let's try this one. 3 over p squared plus p minus 2 minus 1 over p squared minus 1 equals 7 over 2 times p squared plus 3p plus 2. Okay, big equation. Very first step here is to factor all the denominators so you'll know what the LCD is. So rewriting this in factored form, let's see. This trinomial will factor to p plus 2, p minus 1. This is a difference of squares. That's p plus 1, p minus 1. And that will equal 7 over 2 times, that's p plus 2, p plus 1. Okay. So the LCD, I notice I have a 2 in the denominator, so I need a 2. I have a p plus 2 here, so I need a p plus 2. This one also has a p plus 2, but it's only to the first power, so you only need one of them. And I see we have a p plus 1 and we have some p plus 1s and p minus 1, so I need a p plus 1 and a p minus 1. So this is my LCD for the entire equation. So this whole side will be multiplied by 2, p plus 1, or p plus 2, p plus 1, p minus 1. And this whole side on the right, same thing, 2, p plus 2, p plus 1, p minus 1. Let's see what we have here when we distribute now. Okay, if I take this LCD and I multiply it to this fraction, the p plus 2, p minus 1 cancel away. That'll leave me with the 2, the 3, which is 6, and the p plus 1 is left. Okay. Minus this LCD all the way over here multiplied to this. The p plus 1s will cancel, the p minus 1s will cancel, so that'll leave me with the 2 and the p plus 2. Times that 1, but that doesn't do anything. Okay, that's the left side if it is correctly multiplied by the LCD. On the right side, the 2's are gone, the p plus 2's are gone, the p plus 1's are gone, and all I'm left with is 7 and p minus 1. Okay, I've successfully eliminated all the fractions. I will now distribute. And 6p plus 6 minus 2p minus 4. Hang on, there we go. And that equals 7p minus 7. Combine your like terms. 4p plus 2 is equal to 7p minus 7. Subtract 7p from both sides. Subtract 2 from both sides. Negative 3p equals negative 9. That's right. And dividing, and I get p is 3. Now I have to make sure that that doesn't cause division by 0. So let's go back up right here. Let's look here. If you look through all that mess there, this tells me that p cannot be a negative 2. This one right here tells me that p cannot be 1. And this one right here tells me that p cannot be negative 1. So p cannot be any of those, but I've got p equals 3 as my answer. That's okay. It won't cause division by 0. And so 3 is the solution to our equation. Okay, very good. And that, I believe, ends our lesson on solving rational equations.